Good morning, students, and welcome to this second session of Newton's laws. Actually, last time we just barely introduced Newton's laws. So, hope all of you are doing well, and more or less you are done with vectors now, because from today onwards, you will have to put some serious effort into Newton's laws of motion also, in terms of worksheets, assignments, and all these things. Okay. So now, just to take a quick recap of the principles of Newton's laws themselves. So we saw the laws last time. First was the law of inertia, which I'm sure all of you understand well. Second was the force law. This is where we saw that the net external force acting on a body was defined as the rate of change of its linear momentum. So this is the proper statement of Newton's second law, not that F is equal to F. The general statement or the proper statement is that the net external force is equal to rate of change of momentum. Where of course, you know, momentum is defined as mass multiplied by velocity. Okay. So of course, now you have the special case that in this you understand that for a body of fixed mass, that is, mass is constant with respect to time, dp by dt, which is rate of change or differentiation with respect to time of mass into velocity, becomes m into dv by dt, because m is constant, which further becomes mass into acceleration. So we have the net external force is equal to mass into acceleration. So this is the special case of Newton's law, or conditional statement of Newton's second law. You can say that when mass is constant, we can define net force as mass into acceleration. This is, yeah, Shikhar? Mass is obviously a quantity which has only magnitude, cannot be negative. Okay. But more importantly, here we're talking about bodies for which mass is constant. Whereas also we have for variable mass systems, for a variable mass system like a conveyor belt on which mass is being added, or a rocket kind of system is constantly throwing out mass in the form of burning gases, or a leaking tank or something like that, the rate of change of momentum has to be calculated by product law of differentiation. That becomes m dv by dt plus dm by dt, rate of change of mass into velocity. Yeah, that's correct. Okay. So this is this point to keep in mind. Okay, and the third principle of Newton's law is the action-reaction principle. We'll discuss a little more in detail about this today. So the statement of this principle is that every action has an equal and opposite reaction. So what this means properly is that, or in other words, so if a body, let's say E, applies a force, which we are calling action, on another body B, another body, not a vector, denoted by F B comma E. So this is the force which A is applying on B. Then by definition, B must be applying an equal and opposite force. Which we can now call as the reaction. On E. So in terms of a formula, Newton's third law becomes force applied by A on B has this relationship. It is minus of the force applied by B on A. Minus means equal and opposite vectors. So this is the detailed explanation of Newton's third law. How we apply it in actual situations. This is how we visualize the problem and this is how we apply it. Hope this is clear, people. Yeah, so the force on B applied by A. That's equal and opposite to the force on A due to B. Okay, that is what this means. So if I say a vector A is equal to minus of a vector B, that means they are equal and opposite. Equal in magnitude, but opposite in direction. This is the meaning of vector A is equal to minus. Minus sign is to show the direction is opposite. Right? So for example, if this is 10 I cap, this is minus 10 I cap. If this is 10 I cap plus 5 j cap, this will be minus 10 I cap minus 5 j cap. So for example, we have a situation where you have a spring which is attached to a block and there is a person who is pushing the block. The person is pushing the block with a force F. So the person will experience an equal and opposite force. And similarly, the spring will apply what we call a tensional force. So on the block, what will happen is, this is the force applied by the person, by the man on the block. This is the tension force on the block, again applied by the spring. Now if you see the spring, that will experience an equal and opposite tension, now like this. If you see the person will experience an equal and opposite force like this. This is now by the block on the person. This is now by the block on the spring. So these two forces, you can see this tension and this tension, equal and opposite. They are an action-reaction pair. These two forces, the force applied by the person on the block, and in turn the person is experiencing an equal and opposite force because of the block. So these are also an action-reaction pair. Like that, all forces act in action-reaction terms. Hope the concept is clear with the example I placed now. Okay, so first of all, is the example clear to all of you? Yeah, I'll scroll up. You can write, don't worry. But first thing is, make sure you understand what I'm saying. Is the concept of action reaction clear? Yeah, things move because. Okay, Shikhar, I'll explain your point. Action and reaction are not acting on the same thing, no? They're not acting on the same body. Shikhar, to answer your point, if I am applying a force of F on this body, so this body is only experiencing force now, F. It's not experiencing the reaction. तो इस पे नेट फोर्स कितना हो जा रहा है? इस पे नेट फोर्स तो F ही हो रहा है ना, जीरो थोड़ी हो रहा है. So it will accelerate. Who's experiencing the reaction force? I am experiencing. That's a separate matter. So if there is no friction between me and the floor, I will tend to slip backwards. If there is friction, then okay, that friction will balance that, and my acceleration will be zero because the reaction force that I'm experiencing is balanced by friction on the floor. That's not allowing me to slip. Okay, is it clear now? Yeah, so note down the principle and the equation, then we'll come back to the example. So the important thing that the equation shows you that action and reaction don't act on the same object. If A is applying a force on B, B is applying an equal and opposite force on A. So action and reaction are never acting on the same object. So they don't cancel each other for a given object or for a given block. So this is the tension acting on, you can see this one is the tension which is acting on the block applied by the spring. And this one is the equal and opposite tension which is acting on the spring because of the block. So on the person, there is a reaction force acting because of the block, which is towards the left. So that is giving a tendency to slip backwards. But because he is wearing shoes which have friction with respect to the ground, वो slip नहीं कर रहा है. तो उस पे friction कैसे act कर रहा है? Forward direction में act कर रहा है. उसको balance कर रहा है. Let's identify another example. Suppose we have a situation where on a frictionless surface, we have two spherical masses or like two balls like this. Now E is coming with some velocity initially and B is at rest. So when E collides with B, so during that collision, what is happening? During the actual impact, E will be applying some kind of force on B. It will be like this. But B will be applying an equal and opposite reaction force on it. This is the force acting on B because of E. This is the force, the impact force acting on B when A collides with it. So you can think of this as the action of A on B. Now this one will be the force acting on A because of B. So this is a reactionary force which is in the opposite direction. So this is the impact force experienced by E due to B when A collides with B. Or when A impacts. So this one is the reaction of B on E. So you can see that the force on A because of B will be minus of the force on B because of A. In other words, these two forces will be equal in magnitude. Okay. But their directions will be opposite. So like that, all forces that we experience or all forces that we observe in various different systems for various different situations, they always act in action-reaction pairs. Yes, that can happen, or it can stop also. It all depends. There are various different situations that can happen after the impact. Maybe B might go with a velocity, suppose, and this is possible. It might go with a velocity greater than V naught, and E might continue in the same direction. ये भी हो सकता है, but the velocity of E is now becoming less than V naught. ऐसा भी हो सकता है. Okay. Or the situation could be that E comes to rest and B starts moving with some velocity like this. Or it could be that E recoils backwards after the impact, and B starts moving like this. All these different cases are possible. Okay, this is more likely if B is heavy compared to A. This third case is going to be more likely if mass of A is less than mass of B. This is more likely the first case where A only slows down but is continuing in the same direction. This is more likely if A is the heavier object. A's mass is greater than mass of B. No, it can stop it also ना. अरे stop करने के लिए भी तो force चाहिए होता है ना बेटा. वो तो mass और force के relationship पे depend करता है ना. No, Tanish, this is not about ideal conditions. Frictionless surface, that you can say is an ideal condition. No surface is perfectly frictionless. We can only approximate it as frictionless. But action reaction being exactly equal and opposite is a fundamental principle of Newton's second law. It's not an approximation. Yes, the force is opposite. Arey Baba, but this is having a momentum in the positive direction, na? So that force can also result in making the momentum zero. Why are you having difficulty understanding this point? Yes, if the mass of B is greater than the mass of A, it will tend to make A recoil back. If you played carom or snooker or games like that, you will understand this. Think in a game of carom, if you hit the striker with one of the coins, the striker is generally heavier, na? So the coin will tend to recoil back because it's lighter on hitting it. But on the other hand, when you hit the coin with the heavier striker, then it so happens that the striker only seems to slow down and the coin moves forward. All this happens because of the relationship between momentum and force, and we'll discuss more about that numerically. But this example is just to illustrate how action-reaction principle is demonstrated in a collision situation. Okay. Now, action-reaction principle. So they will exchange momentum. Don't worry about that, but I think at different cases we'll discuss. Collisions is an entire chapter in physics, actually. Okay. But right now, just in context of this example, understand what I'm talking about action-reaction. No? Just understand in terms of forces what will happen. This force and this force will be equal and opposite to each other. There can be so many different cases. It need not be like this also. It could be, for example, that this block or this sphere. Now suppose this is you're seeing the carom board from top, and this is your striker, and this is your carom coin. Now suppose it's hitting it in this way. अगर ऐसा hit कर रहा है, then though it's not even a question of recoiling. It'll be like what we call a tangent shot in carom. We call this kind of thing a tangent shot. Na? So suppose this is moving initially with a velocity like this. Body A, which is moving with the initial velocity V0, which is along this line. Now the center of that body B is not lying along this line. So इस केस में तो और ही कुछ हो जाएगा. इस केस में क्या होगा? When they collide during the impact, the force picture will look like this. Okay. So this was the line of A's initial momentum. A's initial momentum was along this line. But you can see that this center to center line is this one now. So the collision forces that will act, which will be along these lines, or rather along this line. So A B पे ऐसा force लगाएगा, and B will apply an equal and opposite force back on A, which will be like this. So this will be your action-reaction pair. So this will be the force acting on B because of A. This will be the force acting on A because of B. Now think in terms of your kinematics now. If the initial velocity is like this and the force is creating an acceleration like this, how the velocity will change? It will change direction. So after impact here, what we'll observe is that E would have had a tendency so as a result of these forces, B was at rest, let's say initially. So B will go off in this direction along that center to center line. B का final velocity ऐसा हो जाएगा. But A's velocity was in this direction. So the momentum was in this direction and then a force acted on it like this. So it created an acceleration which was like this. So this is the direction of the change in momentum, whereas this is the direction of initial momentum. So final momentum will become in some direction like this. So A will go off in some kind of direction like this. This will become A's final velocity after the impact. This will become B's final velocity after the impact. So there are so many different cases possible in collision. But the important thing is this. The action is equal and opposite to the reaction. So the amount of force applied by B on E will always be equal and opposite to the force applied by A on B. This relation will always hold true. So the action-reaction principle holds true even for fundamental forces. If you think about the fundamental forces in physics, something we discussed about on our first lecture, not first lecture of Newton's laws, but first lecture we had in Einstein's law. For example, there is the first type of fundamental force which is called gravitational force. So if you have two particles of mass m1 and m2, which are placed at a distance r, then according to the principle which is called universal law of gravitation, they both attract each other with equal and opposite amount of force. And that force is given by, it's such that it is proportional to product of masses and inversely proportional to square of distance. No, Priyank, an absolutely frictionless surface does not exist in principle. Okay, absolute zero of frictional coefficient is not possible physically. But yes, there are many situations in which the friction is negligible. So for purpose of our experimentation, we can treat it like nearly frictionless. And the constant of proportionality is given by the universal constant of gravitation given by G. This is where capital G is the universal physical constant. Newton meter square per kilogram square. So you can see here also action reaction. The force acting on particle 1 because of particle 2 is negative of the force acting on particle 2 because of particle 1. Because of mass, right? The same reason why you experience weight on the Earth's surface. Universal means it applies in all situations. It's universal, independent of any other condition. This principle is an absolute principle for all masses. That is why it is called the universal law of gravitation. So for example, in everyday life, the weight of a body that you experience on the surface of the earth is because of this same type of force. But there, who's applying the force on the body is the earth's mass. So the earth, as you know, is treated as a giant sphere. So if this is the earth, which has a mass of, let's say, ME and a radius of RE. Now, any body placed on the surface of the earth of mass M will experience a gravitational force towards the center of the earth. That is why that force appears to be vertically downwards. The weight of that body, W, which we write, this is your horizontal plane, tangent to the surface at that point. So it acts vertically downwards. So W, or the weight of the body of mass M, this is nothing but the attraction force, the gravitational attraction force applied by the Earth's mass on the body. This is what is responsible for weight. So that W, which we write as mg, in terms of the Earth's mass and the universal gravitational constant, it is given by this formula. This formula. Okay. Or what we commonly write as acceleration due to gravity on the Earth's surface becomes this, which is approximately 9.8 meters per second square. Okay. Now coming to the action-reaction principle over here. What will happen is that the Earth's center also experiences an equal and opposite force. You don't see the effect of that force at all because the Earth's mass is very huge. The Earth attracts body of mass M on its surface with a force which we call weight as mg. Okay. This body of mass M also attracts Earth with an equal and opposite reaction force. But because the mass of the Earth is very, very heavy compared to the mass of the body, okay, so the body's attraction force on the Earth has negligible effect on the earth. So that is why on the surface of the earth, if you drop a body from a certain height, you see this body accelerating downward with g. You don't see the earth accelerating upwards. Because for the earth's acceleration, let's say if that's a prime, that a prime will be that gravitational force divided by mass of the earth. So it will be small mg divided by mass of the earth. But mass of the earth is infinite compared to the mass of the body. So that acceleration tends to become zero. So there's no effect of that. But that doesn't mean that reaction force does not act. Okay. It very much acts. And this gravitational pull of the earth on that body is equal and opposite to the gravitational pull of that body on earth. The magnitude of that attraction force is given by the universal gravitational formula or law, which is this. So again, this formula is something we'll be studying in detail in a chapter of gravitation. The universal gravitational law formula and applications we'll be studying in detail in a later chapter of gravitation. But as part of general knowledge, you should know this right now. Okay, Rahil, this is one of the fundamental observations in nature. So if you did not understand, I really fail to explain further because that is a fundamental property of nature. You know this from childhood that mass attracts mass. It's an experimental law. There's nothing to understand about it. It's the way things happen. Like electrons attract protons, like protons repel protons. Like that, mass attracts mass. You are present on the Earth's surface because of this gravitational force only. अगर ऐसा कोई force नहीं होता है, तो you would be floating in space. The first and foremost force that we are all used to on the Earth's surface is gravitational force. When you drop an object, it falls to ground. Why does that happen? That happens because of mass and mass interaction only. The Earth's mass is pulling that object's mass down. So that is the most natural force that all of us are used to. That's the first force that we observe in our lives. If you can't explain why mass attracts mass, then how do you explain a body falling to ground when you drop it? When you release an object from a certain height, it should just float in the air. Why it falls to the ground? What is the force responsible for it? It's gravitational force, ना? Gravitational force क्यों आ रहा है? Earth का mass उस body के mass को attract कर रहा है. Mass always attracts mass. This is the most fundamental principle in physics. This you know from 9th year. In fact, you read about this from before that also. Why is the Earth in rotation around the sun? Why it doesn't float off into the galaxy? Because the gravitational pull. What keeps the satellite in an orbit around the Earth, or what keeps the moon in an orbit around the Earth? It's gravitational force. Okay, so those are the three laws. Now, most of this chapter is going to be about application of Newton's second law. So let's look at some examples of applications of Newton's second law again. So when we say applications of Newton's laws, the most prominent one, particularly the second law, that is net force is equal to rate of change of momentum. Let us look at some applications of this. Now, the most easy example you can think of in which we can apply this principle is an object just lying on the ground. You have a block of a certain mass. It's just lying on some horizontal surface. So this is a horizontal floor, and this is a block of mass 20 kg. Okay. So this is at rest. This is lying at rest on the ground. So we want to find the external forces acting on the block. And show the application of the Newton's second law on it. So now if you think about the block, what are the forces acting on the block? First thing we visualize in a problem like this. Yes, very good. That's correct, Anish. Okay. Forces on the block क्या है? कितने हैं और क्या forces हैं? So first of all, there is gravitational pull, you can say, of the Earth on the block, or what we call weight. So that weight is equal to mg and it is vertically downwards. Why will drag be acting better? There's nothing which is pulling the block against the floor. No? You understanding, chicken? I'm explaining. Just be a bit patient. So the first force which acts on this block is the gravitational pull of the earth, which we call weight. And that is equal to mg. And that will be equal to 20 kilograms into, let's take g as 10 meters per second square. We are taking g as the approximate value of 10 meters per second square. So that will be 200 newtons. And its direction will be downwards. Now, secondly, what we can understand is that this weight of the object is pushing it against the floor. Just hang on, Somarup. Let me explain the forces first. Then you come to your own conclusions. So secondly, what is happening is that the weight of the block pushes it against the floor. So what is happening is that the floor is experiencing a downward pushing force like this. Okay, because of the presence of the block. The block getting pulled by gravity downwards in place that is pushing the floor like this. So what is happening? The floor will push back the block with this kind of force. Okay. So this force is called a normal reaction contact force. Okay, the full name for it is normal reaction contact force. Okay. But in short form, we just call it normal force or normal reaction. So, abhi dekho, you have to understand over here, this and this are the action reaction pair. Okay, this is the force with which the block pushes the floor, because gravity is trying to pull it down. So the block is pushing against the floor. So this one now is the reaction force. Okay, this was the action of the block on the floor. Okay, this is the reaction of the floor on the block. So this and this are an action reaction pair. This and this are an action reaction pair. Action reaction pair is not gravity and normal reaction. Okay. So coming back to the diagram of the block, in addition to this weight, it is experiencing an upward force. Okay. And we will denote this upward force by N. This is the normal reaction. Okay. So this is the contact force applied by the floor on the block. You understand? Now we have completed the first part. The forces acting on the block are only these two. There is no other force acting. Here friction will not be acting because the block doesn't have a tendency to be sliding against the floor. No. Friction is a different type of force. It acts along the surface when the body is skidding along the surface or when it is slipping along the surface. But यहाँ पे ऐसा कोई horizontal force ही नहीं है block पे, तो friction नहीं act करेगा, drag force नहीं act करेगा. There will be only two forces. The weight of the block or the gravitational pull of the earth is pulling it down. So if the surface had not been there, or if the surface breaks or something like that, it will accelerate downwards. But here the body is at rest. So instead of the weight dragging the object downwards, what the weight is doing is it's pushing it against the surface, and the surface is applying an equal and opposite reaction force upwards. So that reaction force is denoted by the symbol N because it is called the normal reaction force. Have you understood this? Now, so these are the forces acting. There are only two forces acting. Forces acting on the block are 2 in number, and these are these two. Now we'll apply Newton's second law. Now applying second law, we can see that net force should be equal to rate of change of momentum. Now this is going to be what? 0, because the body is at rest. Okay. So the acceleration of the body is 0. So rate of change of momentum, because it's a constant mass body, which is mass into acceleration, becomes 0. So that means what should happen? The net force acting on the block should be 0. So this means that the net force should be 0. Okay. So that means over here that if I now take a coordinate frame like this, that this is my x-axis, this is my y-axis, so I can see that the normal reaction force is vertically upwards and mg is vertically downwards. So net force क्या होगा? इनका vector sum हो जाएगा. So normal reaction plus mg as vectors, their resultant should be 0. Okay. But if I write them in component form, how much is the normal reaction? It is plus mj cap, because it's acting upwards. And how much is mg? It is minus mg g cap. So that should be 0. So in other words, normal reaction's magnitude should be equal to mg. So that tells me that this normal reaction contact force this n has a magnitude of 200 newtons also, but it acts upwards, vertically upwards, whereas mg is a force which is acting vertically downwards. Okay. So please understand this systematically in the proper language of Newton's experience. All of you know the block will remain at rest, and something is balancing its weight, and that is the contact force that we. Okay. Yeah, just note it down, Shikhar. I'll explain again. If you just note down systematically these points, you'll understand it, because it's actually self-explanatory. But anyway, I'll explain again. Just note this down first. Okay, so 20 kg block at rest on the floor. So the first thing we want to find out, what are the forces acting on the block. So that is on the left hand side of the board now. On the right hand side, we are applying Newton's second law. So Newton's second law, net force is equal to rate of change of momentum. वो क्या कितना हो रहा है यहाँ पे? 0 हो रहा है, because the body is at rest. Its momentum only is 0. So rate of change of momentum will obviously be 0. Differentiation of 0 is 0. So that means the vector sum of all the forces acting on it should be 0. तो यहाँ पे कितने forces act कर रहे हैं? 2 force है. तो उनका vector sum क्या होना चाहिए? 0 होना चाहिए. That is the application of Newton's second law. Is it clear now, Shikhar? Good. Just make a note of this. Hey, Salman, there's the question upstairs there. You've already written it down. How many times you want to write the same thing? Plus, I'm giving you the notes. Understand the part where the explanation is there. Na? This part which you want to write down, this is already there over here. Huh? Okay, let's understand another example now. The concept of normal reaction. So through this example, we have understood one more fact. So the values are clear now finally. Body पे कितने forces लग रहे हैं? दो forces लग रहे हैं. There are two forces, normal reaction and mg, which are finally acting. Now mg's magnitude is 200 newtons. Okay. And normal reaction's magnitude is also 200 newtons. So they are cancelling each other. So your net force is becoming how much? Zero. So acceleration of the body is zero. It is at rest. So that is the final conclusion of Newton's second law. The two forces, they balance each other. Normal reaction and mg balance each other. So your net force is zero. The acceleration of the body is zero. No, Vaishnavi, it is not n is equal to mg is not because of action reaction. Again, see, you're confusing. Mg and n are not action reaction pair. Okay. See what is happening. Normal reaction as a force, who is applying it and who is experiencing it. Okay. This normal reaction it is a force. In fact, it's a contact force applied by the floor, okay, on the block now. And what about gravitational force or mg? It is a force applied by whom? The earth, no? And on whom? This is the weight. This is the force, which is the gravitational attraction. Okay. Applied by the earth, okay, on the body. So how can they be action reaction pair? This mg is a force applied on the body by the earth, and this is a force applied on the body by the floor. So they are not an action reaction pair. Okay. Action reaction pair यहाँ पे क्या होगा? The floor is applying an upward and opposite, upward normal reaction like this, and the body is applying an equal and opposite force on the floor. This is an action reaction pair. Understood? Huh? This is a very common misconception that many people have, that normal reaction is the reaction to gravity. It's not that way. Okay. And whereas, if you look at the thing in proper perspective, there's a tiny mass over here sitting on the surface of the earth. So mg, and now the earth's center or the earth's mass is experiencing an equal and opposite force. So these are the action reaction pairs. Okay. The action and reaction cannot act on the same body. And both these forces are acting on the body. So they cannot be an action reaction pair. You can understood. Okay. So every force has an equal and opposite reaction. So ये जो force है N है, जो body पे act कर रहा है, इसका reaction क्या होगा? इसका रिएक्शन वो वाला फोर्स होगा जो सरफेस पे बॉडी अप्लाई कर रहा है. दिस वन इज द रिएक्शन टू दिस फोर्स. ठीक है. और ये जो mg है जो अर्थ उस पे अप्लाई कर रहा है उसका रिएक्शन क्या होगा? द अर्थ विल बी एक्सपीरियंसिंग बिकॉज ऑफ द बॉडी an attractive force upwards equal to the weight of the body. This one will be the reaction to this. Okay, so those are your action reaction pairs. So remember one thing, that in any situation in Newton's laws, a particular action and its reaction cannot be applied to the same body. because उसका relationship भी ऐसा होता है that F applied by A on B is equal and opposite to the reaction applied by B on E. So both these forces can't be on the same object. Now see here, both these forces are on the same object ना. ये भी body पे ही है और कौन लगा रहा है? Earth लगा रहा है. ये भी body पे है, but who's applying it? The floor. So this force and this force cannot be an action reaction pair. Okay. So this is something very important for all of you to understand. Okay, so this is the final conclusion. The body is at rest because the net force on it is zero. Because the normal reaction and mg, they are balancing each other. All right, let's look at our next example. Now in the same situation, or you can say a similar situation now, but we have two blocks kept on top of each other. On some horizontal surface, and the whole system is at rest. So blocks A and B are at rest, as shown above. This is some kind of a floor again. Okay, so this is the vertical direction, or this is the direction of G. So take G as 10 meters per second square. Now given that mass of A is 2 kilograms and mass of B is 8 kilograms. So first of all, show all forces acting on the block A and the block B. Okay. And secondly, by application of Newton's second law, find the normal reaction on the block E applied by the block B. And secondly, the normal reaction on the block B applied by the floor. Okay. Now you have to just extrapolate a little bit on the last example that we did to understand this. It's not very difficult, but just individually think of each block. So individually think that on A, how many forces are acting, what those forces are, and therefore how you can calculate them by applying Newton's second law. Similarly, individually think on B, what all forces are acting and who is applying them. Okay. Then you'll understand this very easily. Just try this out. Yeah, Ritika, that's correct. Rahil, that's correct. Okay, Shikhar, correct, but just get the values, I mean the magnitudes of the forces also. Okay. So now just think, like you've identified the forces. Now how you will apply Newton's second law from that identification, you know? So block A पे क्या क्या force act हो रहा है? There are only two forces acting on you. One is the gravitational pull of the earth, that is the weight of the block E, which is 20 newtons in this case, and the other is that the normal reaction. Yes, correct. Okay. The normal reaction that block B's surface is applying on block E. So since there are more than one normal reaction involved here, let me call this one N1. Okay. So this is the normal reaction applied by B's upper surface. B's upper surface will apply normal reaction like this. And of course, the acceleration of the block is 0. So the net force should be 0 now. So over here, the net force is N upwards or N1 upwards minus weight of downwards. So the normal reaction should be equal to the weight of E. So this should be 20. So this is A situation. कैसे एक्ट करेगा बताओ शिखर? Is the block A in contact with the floor? नहीं ना. So how will the floor apply any normal reaction on E? Floor, see, normal reaction is a force that only acts between two surfaces which are in contact. तो यहाँ पे A किसके साथ contact में है? ये वाले surface के साथ contact में है ना. तो ये surface इस पे upward force लगाएगा. But the floor is not in contact with E. So the floor is not going to apply any contact force on E. This comes because net force is 0, na? So what is the net force vectorially now? This is upward and this is downward. So it's the difference of the two. The net force's magnitude is how much? The upward normal reaction minus the weight, and that should be 0 because the body is at rest. So its momentum is 0. So rate of change of momentum is 0. Okay, understood na Salman? अच्छा, वो 20 newtons कैसे आया? Because mass इसका दिया हुआ था ना, mass of E was given to us in the problem as 2 kg and G was given to us as 10 meters per second square. So that's why this is 20 newtons. Okay, understood this now? Okay, good. Now let's come to what is happening to the block which is just below this, that block B. So B now experiences 3 forces. Why 3 forces? Because they go, A is sitting on top of it. No? So A is pushing it down with a force the same as magnitude as this, but opposite in direction. Okay. So this is the normal reaction on the block B, but applied by the block A from above. Okay. Then of course there is B's own weight. So the gravitational force that the earth is applying on B. So that is mass of B. That will not depend on mass of E. And that is E into 10 or 18 newtons. 8 kilograms into 10 meters. But now one more force which is acting on B is the normal reaction that the floor is applying on B. So that is acting like this. So this is normal reaction applied by the floor on the block. That one is it. Okay. So ब्लॉक बी को पुश कर रहा है ऐसा नीचे की तरफ, ब्लॉक बी ए को इक्वल एंड ऑपोजिट फोर्स से ऊपर की तरफ पुश कर रहा है. सो दिस इज द N1 फोर्सेस, द नॉर्मल रिएक्शन बिटवीन ए एंड बी. सो बी पे N1 कैसे एक्ट कर रहा है नीचे की तरफ, ए इज पुशिंग बी डाउनवर्ड्स. ए पे नॉर्मल रिएक्शन कैसे एक्ट कर रहा है अपवर्ड्स, बी इज पुशिंग ए अपवर्ड्स. So this is the force with which this is the normal reaction with which the block B pushes E upwards, and this is the reaction to that. This is the normal contact force, or the normal reaction with which E pushes B downwards. So these two are an action reaction pair. This is the force जो B A पे लगा रहा है, that is this one, and the force that equal and opposite force that A is applying on B, that is this one. So these two are an action reaction pair. Is this point clear to all of you? Okay. Now let's come to Newton's second law applied for the object B. So now, for the block B, again what should happen? The net force should be 0 because it is at rest. Now what is the net force with the directionality? You can see N1 is acting downwards, so minus N1 we'll write. Mg is acting downwards, so minus weight. But which is the force which is acting upwards? N2. So the vector sum of all the forces will be this along the y-axis. Now, with proper sign convention, the vector sum of all the forces, the net force is a vector sum. So we don't need to use unit vector notation because सारे forces y-axis के along हैं. But यहाँ पे क्या हो रहा है? If your y-axis is like this, then N1 and Mg, they are acting along minus j cap. So they are coming with a minus sign. Whereas N2 is acting along positive j cap. You understand? So that's how this equation is coming. So this equation is in context of the diagram. In the diagram you can see कि दो forces नीचे की तरफ act कर रहे हैं, N1 and Mg. So they are coming with minus sign, and the third force is acting upwards. Okay. So basically the third force which is acting upwards has to balance the sum of the other two forces which is acting downwards. Okay. So this is now my equation 2, you can say, for the system. This was my equation 1. So now substitute the value of this thing over here. Okay. So from equation 1, we have N1 is equal to 20 newtons. So therefore N2 will become 20 plus 80 because the weight of this guy is 80. So it will become 100 newtons. So the normal reaction applied by the floor on the block B, which is the second thing you were asked, is of magnitude 100 newtons, direction upwards. And the normal reaction applied by B on A was 20 newtons, and its direction was also upwards. So your final answer now becomes like this. Okay. The normal reaction on the block A applied by B is 20 newtons upwards. A पे कैसा normal reaction act कर रहा है B के वजह से? Upward direction. You can see in this diagram, it's upwards. Whereas floor B पे कैसा force लगा रहा है? It's 100 newtons and again upwards. That is a complete solution. No, N1 and N2 are different forces. N2 is the okay. So N2 कैसे act कर रहा है? देखो N2 ऐसे act कर रहा है. B जो है ground पे है, तो B ground पे नीचे की तरफ force लगा रहा है N2, ground B पे ऊपर की तरफ force लगा रहा है N2. This is your action reaction pair. Okay. Whereas N1 is the action reaction pair which is acting between A and B. B is applying upward, A is applying downwards. So these two are an action reaction pair. Okay. These two are an action reaction pair. But no, so this is something you have to be very careful about. Understanding okay, who is applying the force and who is experiencing the force. Okay, so go through each of the diagrams carefully. So first go through the diagram that I made for the block E. Now forget about what's happening to block B over here. Just concentrate on this one. On block A, what all forces are acting is given by this diagram and how we are getting equation 1 from that. So on the block on top, the block A, there are only two forces acting. और उनका वेक्टर सम क्या होना चाहिए? 0 होना चाहिए. बिकॉज ब्लॉक कैसे स्टेट पे है? रेस्ट पे. Okay, so block A's condition is clear, not all of you. Now forget about A and now concentrate fully on B. B पे क्या हो रहा है? This is what is acting. This is what is happening to B. There are three forces in all which are acting on B, and they are creating this situation. This is the situation of block B. Okay, so now just substitute these values, and that's how you will get. Okay, so hope this is clear. So far the two examples we have taken is where the net force is zero. Okay. Now next let us look at a situation where there is some net external force, and we are talking about an object or a body which is actually in motion. So let's take an example where now this is happening. Just a second. Now we come to that situation where it's an assumption that this is a perfectly smooth surface. ठीक है, though in reality ऐसा कुछ होता नहीं है, but this is an assuming an ideal condition where the surface is perfectly frictionless. Okay. Now we have this block of mass, let us say this time 5 kilograms. Okay. And what we are doing is we are applying one force from this side, horizontal force F1, and from the other side we are applying another force in the opposite direction, like this, which is F2. So F1 and F2 are horizontal forces, okay, applied by two external agents. Okay, of magnitudes, let us say 20 newtons and let's say 12.5 newtons respectively. And in opposite directions. Okay. So for example, if N1 is towards the east, then N2 is towards the west. So first of all, show all forces acting on the block. For this, take G equal to 10 meters per second square. So show all the forces acting on the block and their magnitudes and directions. And secondly, apply Newton's second law. Find the acceleration of the block by applying or application of Newton's second law. Okay, so just work this question out quickly. Yes, very good, Shikhar. That is correct. You identified the forces correctly. Now you have to just show their directions properly in a vector diagram. And from that, you have to find out the acceleration by application of Newton's second law. That the net force, that is the vector sum of all the four forces which you have shown me. The vector sum of them should be equal to mass into acceleration because it's a block, so it has a fixed mass. Right. So the acceleration is correct, 1.5 meters per second square, because the net force will become F1 minus F2, which many of you got, most of you got. Okay. So let me just show you the diagram and explain the whole thing in detail. So first of all, as far as force is concerned, what all forces are acting on the body? So you can see the forces acting on the body are F1 this side, F2 from this side. And there are also vertical forces, the gravitational pull of the earth and the normal reaction that the floor is applying. So four forces on all. External forces F1 and F2, the weight of the body and the normal reaction. Okay. Gravity will come into, that's why I said there are four forces. Okay. Now the body will accelerate like this because it's on a floor. So if you take this as your x-axis and you take this as your y-axis, you can see that, okay, of course, the four forces are F1 and F2 are external forces which are given to you. The 20 and 12.5 newtons respectively. mg is going to be 50 newtons because the mass was given to us as 5 kg. So what about the normal reaction? So we should understand that. So now see what's happening. Net force is equal to mass into acceleration. Now break this into components. Okay. So when you break this into components, along your x-axis, your net force should become m into e. Whereas along your y-axis, your net force should become 0. Because you can see that the acceleration is along x-axis, all along the horizontal direction. So when you break this equation F equal to ma, the vector equation, into component form along the horizontal and vertical, is what is happening. So now going back to the diagram, you can see what is the net horizontal force along the x-axis. Where net force kya ho ja raha hai? It is becoming F1 minus F2 because they are opposing each other, but F1 is dominating. So F1 minus F2 is ma. So in this case, 20 minus 12.5 in newtons is equal to 5 in kilograms into E. So that will show you that your acceleration is 7.5 by 5, or your horizontal linear acceleration is 1.5 meters per second square along the positive x direction as shown in the diagram. Whereas along the vertical, what is happening? There are two forces, but mg is acting downwards and normal reaction is acting upwards. So the normal reaction will become equal to mg in magnitude, which will both be 50 newtons. So these are your conclusions. These are the final results that we are getting by applying Newton's second law systematically to this situation, where you can say we are having to do two-dimensional vector analysis because there are vertical forces and there are horizontal forces. Yes, Somoru, that's correct. Understood now? So if you are giving this in vector notation, you could say that the acceleration in my system where I've taken this direction as the x-axis is 1.5 I cap in meters per second square. And similarly, the normal reaction as a vector is 50 J cap because it's acting vertically in newtons. Okay, so hope the vector analysis part is clear. It's pretty simple here because it's just you're calculating the sum of two forces which are in opposite direction. So the angle between them is 180. Na? So the net force just becomes the difference of their magnitudes. Okay. Now in our final example today, you will take a slightly modified version of this question where what is happening is your block is again on a frictionless surface. Okay. But this time, so this is your frictionless floor or surface. So this is a smooth surface in the horizontal plane. Okay. Now on this surface now, let us say we have a block like this line. This is a block of mass 2 kilograms. Now on this block we are applying two horizontal forces, okay. But they are in this sort of direction. One person is pulling it with a force like this and another person is pulling it with a force, let's say like this. So F1 and F2 are external forces applied horizontally, okay, but such that the angle between the two vectors is theta, such that magnitude of F1 is equal to magnitude of F2 is equal to, let us say, 2 newtons. But they are applied at theta equal to 60 degrees with respect to each other. They are applied at theta equal to 60 degrees with respect to each other. So find the acceleration of the block in magnitude. E. So all forces acting on it. Okay, just try this question out. So again, like the previous question only, there are how many forces acting on? There will be 4 forces. Gravity is pulling the object vertically downwards. So it's pushing against the horizontal floor. So the floor is pushing vertically upwards with normal reaction. So weight and normal reaction, 2 forces which are vertical. And then F1 and F2 which are the 2 horizontal forces. Nahi Rahil, it's not. Yeah, Shikhar, your answer is correct. The forces are at 60 degrees. So you can use parallelogram law, no? Or triangle law. So because this is now three-dimensional in a sense. So what you can do is you can take the direction of this force. Suppose you're taking this as your x-axis, okay, and you take the direction of the perpendicular direction over here, this one. Take that as your y-axis. So your xy plane is the horizontal plane, okay, and your vertical is which axis now? It's the z-axis. So vertical axis will become this one. This is your z-axis. Okay. So we'll take a system of axes, or we'll take a coordinate frame such that the xy plane is the horizontal, okay, such that the direction of the force F1 is along I cap or x-axis, okay, and therefore the z-axis becomes the vertical. Okay. So when I draw the diagram of the block, looking at it from sideways, such that I'm seeing it in the xz plane, suppose. I'm seeing it in the xz plane. इसमें मुझे क्या-क्या forces दिखेंगे? There will be gravitational force acting downwards. And there will be normal reaction acting upwards. Now in this diagram, I'm showing only vertical forces. So here we are showing only the vertical forces. So this is not a complete diagram. Okay, this is only showing the vertical forces. There are also horizontal forces. So along the vertical direction, my acceleration is 0. So vertical forces should balance, because the vertical acceleration Az is 0. So normal reaction should balance mg. And that is 20 newtons, whatever that was. Okay. So this is not the complete thing yet. Okay. This is only showing 2 of the forces out of the 4. Just like this. Okay. So this is the diagram in the vertical plane. XZ plane is the vertical plane. This is in the vertical plane. These are the forces which I'm showing. Now, let's look at the diagram in the horizontal plane. So if we take what we call the top view, मतलब आप ऊपर से नीचे देख रहे हो. So you're looking into the horizontal plane. So XY plane is the horizontal plane. Okay. So you're seeing the object like a box from the top. Now उस पे जो forces act कर रहे हैं वो कैसे हैं? There are forces F1 like this along the x-axis, and the second force F2 like this, but at 60 degrees. So F1 and F2, okay, and this angle is 60 degrees. So net force कैसा हो जाएगा? The net force that is acting on the body will be the vector sum of F1 and F2. So the net force will be in this sort of direction. This will become F1 plus F2, which will become the net force. Okay. So the body will accelerate in the direction of the net force. So block का acceleration कैसा होगा? It will be along this direction. Accelerate along this direction. Understand? So now you have to just apply your knowledge of vector algebra. Okay. So F net is F1 plus F2. Now in this, the magnitudes of F1 and F2 are given to you. They are both 2 newtons each, and theta is equal to 60 degrees. So just apply 2 ही था ना कि 4 था. Two newtons each. Okay. Okay. So now just apply parallelogram law. Root of F1 square plus F2 square plus 2 times F1 F2 cos theta. It's like this. So it is 2√3 newtons. That is the net force. Correct. So net force is equal to mass into acceleration. So the magnitude of the acceleration is the magnitude of net force divided by the mass. So the acceleration magnitude is becoming √3 meters per second because the mass was 2 kg. So this is the complete solution of this question. Understood? So vertical forces mg and normal reaction are balancing each other, whereas the forces F1 and F2 which we are applying in the horizontal plane, they are in such a way that they are at 60 degrees to each other and their magnitude is equal. So their vector sum is coming from this principle. तो वही use किया ना बेटा. So this is becoming square root of 4 plus 4 plus 4. So that is 2√3. ठीक है. So on that horizontal plane, this was your horizontal plane, and the block is lying like this over here. So ultimately, we are seeing what is happening here. You have vertical forces, normal reaction, and mg, which are balancing each other. But you also have the external forces which are acting in the horizontal plane. So this F1 is acting along the x-axis, but F2 is acting at 60 degrees. So ultimately, the block will end up accelerating in the direction that bisects F1 and F2. The block will end up accelerating along this axis. Accelerate along this direction in that horizontal plane. So to make things simple over here, because this is a 3-dimensional diagram, I have first looked at it from the side. So I am looking into the vertical plane and the vertical forces are balancing each other in the XZ plane. Then I am looking at it from the top. Okay, so I am looking into the floor, into the horizontal XY plane. So I am seeing the horizontal forces F1 and F2, both of which are equal in magnitude but at an angle of 60. So their net is along this direction, which is the diagonal of the rhombus. So remember, it will bisect it. So ये angle 30 degrees हो जाएगा. ये angle 30 degrees हो जाएगा. Okay, but anyway, here you are asked to find only the magnitude of the acceleration. So that is becoming like this. Okay, people. So hope this example is clear, and with this we conclude today's session. Okay, so now that we have understood how to apply vector algebra to find the net force when multiple forces are acting on an object, and from that find the acceleration using Newton's second law, that net force is equal to mass into acceleration. So you will be given a worksheet now where you'll have some practice questions based on this. And in general, the Newton's laws principles, net force is equal to rate of change of momentum or mass into acceleration. Every action has an equal and opposite reaction and all these things. Okay. So that's it for today's class, people. And as I said, just make sure you revise the notes and the recording if required, and then start the assignment problems which I'll be sending